Today we're going to talk about balancing chemical equations, but first I'd like to go over some vocabulary. A chemical change is the reorganization of atoms in one or more substances. Bonds are broken and new bonds are formed. A chemical equation is a representation of a chemical change. It tells us the identities and the relative quantities of the substances that are undergoing the chemical change. In other words, what these substances are and what the amounts of them are. Now, the reactants in a chemical equation, these are the compounds that you start with. They're on the left-hand side of the arrow. The products are what you end up with. They're on the right-hand side of the chemical equation. The coefficients are the numbers that are right in front of the formulas for the molecules. They tell us the relative numbers of each reactant or product species. Usually the smallest whole number coefficients are used. Now you can think about this as kind of being like simplifying fractions. In this particular equation, we have 2 molecules of nitrogen and 5 molecules of oxygen for every 2 molecules of dinitrogen pentoxide. This slide shows a particle diagram for a balanced equation. We like to represent equations in many different ways, and the particle diagram is nice because it can really help you visualize what's going on. On the left-hand side, we have a methane molecule. It reacts with 2 oxygen molecules. In this particle diagram, you can see that each oxygen molecule has 2 oxygens in it. We call this diatomic oxygen. In nature, oxygen likes to exist as 2 oxygen atoms bonded together. Now, over on the product side, the particle diagram shows a representation of carbon dioxide, and you can also see the 2 water molecules. Particle diagrams are an example of a scientific model, and they're good for really visualizing what's going on in the reaction. Now, these equations can be interpreted in several different ways. A moment ago, I was talking about numbers of molecules. These equations can also be interpreted as representing the number of moles of each molecule, and the information can also be used to find the relative number of atoms of each type of molecule, or the masses of each type, or even the total masses of the reactants and the products. Some chemical equations will also specify the phase of the reactants and the products. For example, we have special symbols that will tell us if the particular compound we're looking at is a solid, a liquid, a gas, or aqueous, which is a term that means dissolved in water. Solid is represented by an S in parentheses, liquid by an L in parentheses, gas by a G, and aqueous by an AQ. Though we may not see these symbols so much in general chemistry, you're going to see them a lot in AP chemistry, and it makes a big difference. Now let's talk about balancing a chemical equation. In a chemical reaction, atoms are neither created nor destroyed. This is our law of conservation of mass. There must be the same number of each type of atom on the product side as there is on the reactant side. And I want to go back to this particle diagram and take a look at it for a moment. If we look on the reactant side, we'll see that we have 1 carbon. And if we go to the product side, we can also see that we have 1 carbon atom. It's the black one. Now let's go back to the reactant side again. We have 4 hydrogen. We count 1, 2, 3, 4 little white balls. And if we go to the product side, we also have 4 hydrogens. Back to the reactant side, 4 little red balls. That's 4 oxygen. And when we go over to the product side, you can see we also have 4 oxygens. The number of atoms on the left-hand side, the reactant side, equals the number of atoms on the right-hand side, the product side. Making sure this rule is obeyed is called balancing a chemical equation. So let's go through the steps for balancing equations. The first thing you need to do is determine what reaction is occurring, what the reactants are, what the products are, and if you have the information, what the physical states are. The next thing you're going to do is write the unbalanced equation that summarizes the reaction. You will balance the equation by inspection. This is basically systematic trial and error. You want to start with the most complicated molecules and determine which coefficients, those numbers at the front of the compound, are necessary so that the same number of each atom appears in both the reactants and the product sides. Make sure you don't change the identities of the reactants or the products. For example, don't accidentally leave out the 2 in H2O, or you'll be left with a hydroxide ion, which is very different than water. Last thing is to check and see if your final equation is balanced. Okay, so now let's go through an example. We are told that molecular nitrogen reacts with oxygen to form dinitrogen pentoxide. The first thing we're going to do is determine our formula. So I know that in nature, nitrogen and oxygen both like to come in diatomic forms. That means 2 of them together. So N2 is my formula for nitrogen and O2 for oxygen. Now let's go over to the right-hand side. Dinitrogen, that means 2 nitrogens, and pentoxide, that means 5 oxygens. So this is my unbalanced equation. Now the next thing we're going to do is balance by inspection. I'm going to start by counting the number of each type of atom on both the reactants and the product side. So on our reactant side, we have 2 nitrogens and 2 oxygens. Let's go over to the product side. We have 2 nitrogens and 5 oxygens. Remember, those subscripts tell us how many atoms of a certain element are in the molecule. Now, as I look at this, I notice that the number of nitrogens is the same on both sides, but the number of oxygens is different. There are 2 on my reactant side and 5 on my product side, so this equation is not balanced. Now, in order to balance this, I am going to have to change some of the coefficients. But I have to do this in such a way that I get the number of atoms on the reactant side to match the number on the product side. Unfortunately, this can take a little trial and error. One of the suggestions is to start with the most complicated molecule. So we're going to start with the dinitrogen pentoxide. So I have 5 oxygens, but I only have 2 oxygens on the reactant side. I notice that if I were to multiply the dinitrogen pentoxide by a coefficient of 2 and the oxygens by a coefficient of 5, I would get 10 oxygens on both sides. That 2 subscript on the oxygen tells us that there are 2 atoms of oxygen in that molecule. Multiply 2 times 5, that's 10. Same thing over on the product side. That 5 subscript on the oxygen tells us there are 5 oxygen atoms in that molecule. If we multiply it by 2, we get 10. So right now, our oxygen is balanced. However, we're going to have to double check our nitrogens again. By adding a coefficient of 2 to the dinitrogen pentoxide, we have not only doubled the amount of oxygen atoms, we have doubled the amount of nitrogen atoms on that side. So now instead of having 2 nitrogens, we have 4. In order to balance this equation, we need to make sure we have 2 nitrogens in the reactant side. If we put a coefficient of 2 in front of the nitrogen molecule, that will give us 4 nitrogens on the left-hand side of the equation. Now let's check one more time to make sure our equation is balanced. 4 nitrogens on the reactant side, 4 nitrogens on the product side, 10 oxygens on the reactant side, and 10 on the product side. This is a balanced equation. Now let's go for a more difficult one. Barium nitride reacts with water to form barium hydroxide and ammonia. The first thing I need to do is determine what the reaction is, and I need to write down the unbalanced equation. I'm going to leave gaps between each molecular formula so I have room to put coefficients in. Now I have to balance my inspection. I look at the reactant side and I see that I have 3 barium atoms, 2 nitrogen, 2 hydrogens, and 1 oxygen. Now I go to the product side and I see that I have 1 barium, 1 nitrogen, 5 hydrogens, and 2 oxygens. I had to add things up to get my hydrogens because they're in 2 different molecules. In the barium hydroxide, there are 2 hydrogens. We multiply that subscript 2 by the hydrogen inside the parentheses. The ammonia has 3 hydrogens, so 2 plus 3 is 5. I'm going to start by balancing my bariums. I have 3 bariums in the reactants on the left, but only 1 on the right. So I am going to add a coefficient of 3 in front of the barium hydroxide. Now I have 3 barium atoms, but I also have to multiply the other atoms in this molecule by 3. So I have to change my oxygens to 6. This molecule has 2 hydrogens in it. I also have to multiply those by 3. So I get 6 hydrogens. But I'm not done yet. I still have to add those to the 3 hydrogens in the ammonia molecule. So when I do that, I get 9 hydrogens. Okay, let's step back and look at this equation again. My bariums are balanced, but nothing else is. What can I do to make things equal? I notice I have 2 nitrogens on the left-hand side and 1 on the right. So if I add a coefficient of 2 in front of the ammonia, that's going to give me the 2 nitrogens on the product side I need. Unfortunately, what that's also done is increase my number of hydrogen atoms. I have 3 hydrogen atoms in the ammonia molecule, but I have to multiply them by the coefficient of 2. So I have 6 hydrogens in that molecule now. I have to account for those. So remember, we have 6 hydrogens from barium hydroxide after we added the coefficient of 3. We have to add those to the 6 hydrogen atoms of ammonia we have. This gives us 12 total hydrogens. Now let's step back and look at our equation again. We have 3 barium atoms on each side. We have 2 nitrogen atoms on each side. However, our hydrogens and oxygens are not balanced. Somehow, we need 12 hydrogens and 6 oxygens. If we were to put the coefficient 6 in front of our water, that would give us 6 times 2 hydrogens and 6 times 1 oxygens. That's 12 hydrogens and 6 oxygens. And now we check to see if our equation's balanced. We have the same number of each atom on both sides of the equation. We have fulfilled the law of conservation of mass, and this equation is balanced. So by now you should know some of the basic steps for balancing chemical equations. But getting good at balancing requires a lot of practice. There's so much trial and error, and each equation is going to be a little different. Balancing can be tricky, but don't get discouraged. Practice makes perfect. You can totally do this.